everyone, welcome back to my channel Science Sutra. In this video, we will be discussing with a new concept, that is related to light, reflection and refraction, and in this concept, we are going to see some rules which we need to follow while studying the reflection by spherical mirrors. What is the topic means? Sign convention for reflection by spherical mirrors. Why we need to study all that I will discuss later. First, in this, if we want to study this, we need to follow some rules. What are the rules which we need to follow while studying the reflection by spherical mirrors? What is the first rule? First rule, as we know, when we are talking about a spherical mirror, right? When we are talking about any spherical mirror, if you take this is a concave mirror, what you will see here? You will see the pole, right? The center point of any reflecting surface of a spherical mirror is called pole, right? And in this sign convention, that is called to be new Cartesian sign convention. The name of this sign convention is new Cartesian sign convention. In this, what we had to do? We have to take the pole P as the center point of this Cartesian sign convention. See, we have to imagine an imaginary axis that is passing through the pole, as well as like horizontal line that is passing through the pole. As we know, when we are talking about the coordinates, we know this is called to be the origin, right? Generally it is represented by O, but in this case it is represented by P. P is called to be the center of this new Cartesian sign convention. And what we have studied? We have studied that it has x-axis, right? It has y-axis. Whatever the points that is coming under the right side of you, that is coming under the right side of this, is called to be positive, right? The right part of this axis is called to be positive, whereas the left part of the x-axis is called to be negative, right? We know that. And even the y-axis, if we go upside, we will see the positive y-axis, y points, and if we go down, we see the negative y points. The same thing we have to apply here also. We have to consider the pole to be the center point. And we have to consider the object. Whatever the object that we are taking, it should be always to the left side of the reflecting surface. We have to take like that. What is the first rule? The object should always be considered to the left hand side, of the reflecting surface. Reflecting surface, right? Next, for example, I will take this is the object, that is A and B. And I want to measure the distance of this object from the pole. How I need to measure? I need to measure the distance from the pole like this. I need to measure the distance like this from the pole. Generally, the object distance is generally denoted by the symbol U. That is the second rule. What is the second rule? The distances measured should always be from the pole. Whatever the distance that we will measure, that should be measured from the pole. Okay. The third point. What is the third point? The distances parallel to the principal axis always measured from the pole. Okay, this point you can write like this. Whatever the point that I mentioned as 2, you can write this as the distances parallel to the principal axis is always measured from the pole. Okay, these are some of the rules, and still more are there, you have to know. Here, what is the third point? If I take the third point, what is that third point? The distances which are measured to the left side is taken negative, whereas the distances measured to the right side is taken to be positive. This is main important point. Okay, whatever the distances that you are measuring, okay, to the left side, we have to consider that as negative, and whatever the distances that we are measuring to the right side, we have to consider that as positive. And one more point. What is that point means? The distances perpendicular to the principal axis, perpendicular to the principal axis, but above the principal axis. If it is this the case, but above the principal axis. If the case is like this, then we have to consider the distances to be positive. The distances perpendicular to the principal axis but above the axis is taken to be positive. Okay. And the distances perpendicular to the principal axis, but below the axis is taken to be negative. See, for each point I will write the diagram so that you will get to understand easily. See, for this, what I am saying, whatever the distances that is measuring to the left side of you, this is left side, so I am taking this as negative and this as positive, that is minus x-axis and plus x-axis. Okay, in this case, what I am saying here, whatever the distances that is perpendicular, if I take here, this is the perpendicular, okay, this is above the principal axis, right? What is principal axis? Whatever the line that is passing through the pole, focus as well as the center of curvature, that line is called to be the principal axis, right? And whatever the distances that is perpendicular to the principal axis but above the axis, in this case we have to take positive, but in this case if I consider the point like this, downwards, okay, if the point like this, if it is pointing downwards, then this distance is considered to be negative. I am talking here the y-axis. Okay, here what I am talking, it is about the x-axis, and here what I am talking, it is about the y-axis, right? If we measure the y points upside, what we will get? We will get the positive y, right? If we measure the points to the down, here in this case, if we measure the points to down, what we will see? We will see the negative y-axis, right? That is the thing here. The distance is perpendicular to the principal axis, but below the axis is taken to be negative. These 5 rules you have to keep in mind. Okay. See, for solving some problems, these are the rules which you have to follow. Okay. Yes. In the next, what you will see, whatever I wrote in terms of draw diagrammatically for you. Okay. What is that means? I am taking any spherical mirror. Okay. Any spherical mirror. In this case I am taking concave mirror, or generally you can take this as spherical mirror. Okay. Spherical mirror. What is the first rule? I need to consider the object to the left side of you, right? I need to consider the object here to the left side, right? And what is the distance of this? See, if I want to measure the distance of this object from the pole only, I need to measure, right? From here, I need to measure till pole, right? So, this is how I need to measure the distances of this object from the pole. That is the second point. All the distances should be measured from the pole. And if I take, this is the direction of what? Direction of incident light. Direction of incident light. Correct? And if I take, this is negative value. Whatever value that I am taking here, it is a negative value. And here you will see the point. How can I write? This is distances measured to left side. Distances measured to left side is taken negative, and whatever the distances measured to the right is called to be positive, right? That is what I am explaining. And whatever the distance is perpendicular to the principal axis, that is above, we have to consider the positive, and whatever the distances that we are taking down, that is taken to be negative. And here I can take this as y-axis, and here I can take that as x-axis. Okay, whatever points I discussed, that I have written diagrammatically, which you can easily understand. Okay, if you know these points, it will be easy for you to solve the problems. Okay, and this is about the general. Generally, I am talking about the spherical mirrors. But in case if we want to solve for either for concave or convex mirror, what will be the case that I will discuss. Okay. Yes, all the rules which I discussed, that how it will be applied to convex mirror or concave. First I will take concave mirror. Okay, how it will be applied to concave mirror we need to discuss. Okay, first we need to discuss for concave mirror. See, while writing the ray diagrams, we have observed that what we have observed, the image that we are getting from a concave mirror, it will be an enlarged image, right? Enlarged image, then it will be real as well as inverted image. That is main here. Image, if I am talking about the image, how we are getting in case of concave mirror, we are getting enlarged. Okay, but one exceptional case is there where you will get a diminished image. Generally you will get enlarged image, as well as what else, you will get a real as well as real and inverted image you will get in case of concave mirror. Okay, and I will take the diagram like this, where I will write this is a concave mirror, right? Concave mirror. Concave mirror, and here I can I can mark the points here. This is pole, right? And for a concave mirror, how we will write the center of curvature? It will be towards the left side, right? center of curvature, and here you will see the principal focus. And what else you will see? We have to consider the object towards the left side, correct? And here, as I told, the image, the object distance, from where we have to measure from the pole, right? Since the image that we are getting real, where the image it will be, generally we can take at any point, but it should be in front of the mirror, not behind the mirror. You cannot consider the image somewhere here, right? Because since it is a real as well as inverted image, I will take somewhere here. Okay, this is the image point. I will take like B dash and A dash, and the distance of this image to the pole, it is denoted by V. Okay, so it is V and this is U. Okay, this is the object distance U and this is the image distance V. Okay, and what else I told? We had to consider the, if I'm talking about the image distance, okay, U, what will be the sign for U? It will be negative, right? Object distance, since it is towards the left side, we have to consider that as negative, right? What about the image distance? It is also negative for concave mirror. Okay, and what else? If I am talking about this, what is this? Height of the object. Okay, I will take as HO, and here this is height of the image, that is HI. Since HO is above the principal axis, right? This is the principal axis. This is the principal axis. Since it is above the principal axis, we have to consider this as positive, but HI is negative since it is below the axis. Why? Because we are getting inverted image. So we have to consider HI to be negative in this case. And if I am talking about the radius of curvature of this concave mirror, it will be negative, right? We are measuring towards the left side of this axis. So R is negative. And these are the points, okay, which I have to keep in mind about the sign convention, whatever I am explaining to you. The sign convention you have to keep in mind for solving. Yes. And one more point, this focus, focal length. How can you determine focal length? We have to measure the distance between principal focus and the pole, that is denoted by small f. And here in this case, small f will be negative. Why? Because it is coming towards the left side of U, right? So we have to consider that f to be negative. All these points you have to keep in mind before solving problems. Okay, and this is for concave mirror. Yeah, this is the case where we will see in concave mirror. Okay, but why we need to learn this, right? You may have this doubt, right? Why we need to learn this, right? We know if I take a concave mirror like this, okay, what happens? You may see the position of the object to be here, right? Let me take like U to be 6 centimeters away from pole, okay? And here I will take the center of curvature, focus and pole. What happens after reflection? What happens? I will see, okay, I will see the image to be formed somewhere here. Okay, let me take at C. It is formed here. But what is my question is that we know, but we have not measured the distance perfectly. We don't know the distance of the image from the pole, right? We cannot measure that. Okay, then how we can measure the distance of the image from the pole? It is measured by using the formula. Okay, for that purpose we need to learn this conventions, sign conventions we need to be perfect with. And what else? The sign conventions where we need to apply while solving the problems. See, if they ask you for a concave mirror, okay, what all things should come to your mind at first? The object should be taken with a negative sign, whereas the image should also be taken with a negative sign. The object height to be taken positive, and the image height to be taken negative. Why? We are getting real as well as inverted image in the case of concave mirror, right? And R, what about the R? R is the radius of curvature, which we have to take negative in the case of concave mirror. This is all about the concave mirror. See, if I apply the same things to convex mirror, how we can write that we need to know. Okay, I will take the convex mirror where the reflecting surface of the convex mirror will be outwards, right? So if I want to mark the pole, the mark of the pole will be here, right? And what else we need to mark? We have to mark the center of curvature as well as the principal focus. All the pole will be at center of curvature, and the principal focus will be at the right side of you, right? It will be at the right side. So what we have to take? We have to take here, but the object should always be taken to the left side of you. So whatever the distance that we will measure, that as u to be negative in both the cases, but the image which is formed, it will be positive. I will take positive. Why? Because in convex mirror, what kind of image we are getting? In convex mirror, we are getting virtual. We are getting virtual as well as erect images, right? So if you see the ray diagrams where you will see the nature of the image, if you see the nature of the image, you will get to know the nature will be virtual as well as erect, right? So I have taken the V to be positive. Why? I am taking the image to be somewhere here. So I will measure the V distance to be positive in the case of convex mirror, correct? Then what about the focal length? The focal length will also be positive because the principal focus, whatever we are taking, it will be on the right side, right? And what else? The height of the object, it will be positive, whereas the height of the image is also positive in convex mirror, right? And what else? Radius of curvature is positive since we are taking towards the right side of you. So whatever the conventions that I am giving to you, you should be perfect with the conventions. Okay, so that whatever the conventions that I am explaining to you, you should be perfect. So it will be helpful for you to solve further problems. Okay, and there is one formula. What is the formula? That is called mirror formula. Okay, this formula is very much important for solving some problems related to this concept. Okay, mirror formula. What is that formula? The formula shows the relation between focal length, object distance as well as the image distance. Then how it has been related? It has been related like this: 1 by f is equal to 1 by u plus 1 by v, where u is the object distance, v is the image distance, and f is the focal length, right? So this is the mirror formula. See, if you know one quantity, like if you know the focal length and if you know the image distance, then automatically you can find out the object distance using this formula. Okay, next there is one more concept called magnification. What the word implies? Do you know the meaning of magnify? To see an enlarged image, right? Sometimes you may see the magnification to be low, right? It to be low. Sometimes M to be very much high, right? That means the enlarging power of the lens or the mirror will be more, and sometimes it will be very much less. That means we are getting a diminished image sometimes, and sometimes we are getting an enlarged image. It all depends on the position of the object, okay, and it all depends on the incident rays that we are considering, right? So then how we can relate the magnification with the object distance and the image distance? It is given by a simple formula, that is h prime by h, which is equal to minus v by u, where is h prime called to be the image height, okay, and h is called to be the object height. Okay, don't get confused here. If you want, you can write down here, this is I, this is O. Okay, like this you can mention it out. This is the object height and this is the image height. These two were related through the negative sign, okay, of the image distance to the object distance. Okay, this is the one more formula which we need to use to solve some problems later. Okay, if m is negative, if you are getting, after solving this, if you are getting m to be negative, what does it mean? It means the image is real, okay. And if m is positive, what does it mean? It means the image is virtual, okay, virtual. And while solving the problems, you have to be careful if whether they have given the convex lens or a concave lens. Okay, please read the question properly, then you have to take the correct signs for V and U, so you can solve the problem easily. But whether it may be positive, whether it may be negative, this negative sign you should take always, okay. With the negative sign you have to multiply with V and U, okay. This is the magnification formula which you need to remember while solving some problems relating to this. Okay, this ends this video, and in this video I taught you about sign conventions both for convex and concave mirrors, and I had told the relation between the focal length and the object image distance. And one more which I taught to you, it's about the magnification. Okay, the magnification formula is related like this, okay, through a negative sign of V to U. Okay, this formulas, whatever I told, you have to please go through that. Okay, you have to mark down what I told to you. Okay, after marking, after reading this, you can easily solve the problems which I will discuss in my next video. Thank you. If you like this video, please like, share and subscribe to your friends. Okay, so it may be helpful for everyone. Thank you.